Hello students, so let's try to solve one very nice problem from IIT JAM examination, and this exam was held into 2024 and it's a very wonderful problem. So in this particular potential we have potential is equal to 0 for x is minus a by 2 to plus a by 2 and infinity otherwise. So this is your potential. So this is my potential. The particle is trapped inside this particular square potential box, that is from minus infinity and plus infinity. And it is given EE and psi is the ground state energy and corresponding wave function for the electron. So it is given EE and psi E ground state for electron. And similarly, it is also given E mu and psi mu is the ground state for muon. So this is given. So we have to choose which one of the following is correct energy as well as correct wave function for the muon as well as electron. And these are the options. So when we are going for the option, in the option 1, it is said that energy of muon and electron will same as well as wave function is also same. And here this is our muon wave function and this is our electron wave function, and this is our muon wave function and this is also muon wave function. So this is, and in this option the energy is going to be different, and here the energy is also going to be different, but wave function is something like this. So how we can go for this? So students, in this type of problem we have to think very carefully. Here both electron and muon are not going to interact each other. This is one very interesting thing. And we can assume that electron and muon are in two different boxes. And if they are into the two different boxes, then the energy level and the wave function of the electron will defined separately, as well as the energy level of and wave function of muon will also defined separately. So now, hence, this is the symmetric potential. So if it is symmetric potential, so whatever is the particle, the ground state wave function will be something like this. This will be the wave function for your ground state. And it is said that muon is also into the ground state and electron is also into the ground state. So if both are in ground state, then this will be the wave function psi E will have same type of wave function as well as psi mu have also same type of wave function. This is one of the information because both are in the ground state. We have nothing to do with the muon and we have nothing to do with the electron. The what will be the because both we can treat it independently. And now the second is energy eigenvalue, and we know the energy eigenvalue En is equal to n square pi square h cut square upon 2m a square. And for the ground state, n is equal to 1 in for all particle, whatever it is, either muon as well as you have electron. Now, so for the electron, what we have, En is equal to pi square h cut square upon 2me a square. This is for the electron. And we have E1, and this will be for the ground state. So we can write E1E, and E1 muon is also pi square h cut square upon 2mu a square. And what is the next information? We have to know that mass of electron is less than mass of muon. So what will happen? So yes, the energy difference between muon and electron will be different. And yes, the electron energy will be higher than the muon energy. So yes, electron energy is higher with respect to muon 1, but the nature of wave function will be always same for the ground state, and it will have a cos function. So the best option is all about here. in the first option, electron and muon, the energy of electron and muon is same, which is not correct because masses are different. So this is not a correct. And it is given that it is a sine 2 pi x. Sine 2 pi x is the wave function for the first excited state. So this is not correct. Here the energy of muon and electron is different. So, but wave function is not correct. Here also wave function is not correct because you have basically the ground state energy for the muon and electron will be the cos function. So this is sine function. This will be first excited state. So yes, only one option is correct. That is option number C, where energy of electron is greater than energy of muon, but both are into the ground state. So both have the cos function, and here the muon have cos function. So we have this one as a correct option. So option C is the correct one. Thank you, students.